So welcome everybody, vast hordes of you. My name is James. I'm a technical trainer for Harman, the luxury audio group in Europe. We're not just in Europe, we're luxury audio group worldwide, but I cover Europe. I'm here to...
You're based in Munich, the luxury...
No. We're based in Cambridge. Cambridge in the UK. Actually, you mentioned that, but it's part of my presentation. So, welcome all. Just a little synopsis of what I'm going to do. I'm going to cover a bit about Arcam. So the product I'm introducing today is the Arcam SA30. Arcam as a brand has a proud history, and it's within the last 2 years that it became part of Harman, that has helped us, and Harman have very much invested in Arcam, not just as a brand but also as a group of people. We are not just the Cambridge office that was the Arcam office is still the Arcam office. It's still the centre of development for new Arcam products and also Lexicon products, and all our worldwide luxury audio group service support is based out of Cambridge now as well. So it's a hive of activity and a place that's growing in functionality. So it's been super positive, and we couldn't be happier. So we'll have one run through about just where Arcam have come from as a brand, and then I'll introduce you the HDA range and the SA30 that's joining it. So for those of you who don't know, and I hope if you haven't ever been to Cambridge in the UK that you do at some point, because it's a beautiful city. It's dominated by the university, but it's... Sorry? And the boats, yes. The River Cam has given its name. It's a truly beautiful city, and I've only recently moved there myself, but Arcam started in Cambridge and remains in Cambridge. Our founder is a chap called John Dawson. He's worked on every Arcam product and continues to do so. He studied at Cambridge. He's from the area, and that's John in the middle. He's a very, very clever chap, and he's never one to be shy about talking about the technology and his ideas and the thoughts and processes that go into developing audio products. Yes, John did study at the University of Cambridge, and he holds a graduate degree from there, from Trinity College. And after university, he, with a friend from university, he started what at the time was called A&R Cambridge. That was Audio and Recording Cambridge. It was known as. A few years later, they released their first product, which was the A60 amplifier. And we still talk about this amplifier quite a lot, even though it's 40 years old plus. And that's because it was the first product that John put all of his ideas into. And it's quite a small thing when you see it. It's not a huge, great lump of an amplifier. But there were some very simple principles that John wanted to put into effect. And one of those was the oversized transformer for an amplifier of its power output. The transformer was way too big. Obviously, you can see it's by far the biggest thing in there. And the other thing was a single board.
Figure about the noise. How small or weak is the noise? You say low noise? So
No, not off the top of my head. John could. Yes. Yeah. John could measure it. There it is. It's vanishingly low, but obviously we can do a much better job nowadays. The technology has moved on, but one of the reasons why we continue to show images of this product is that single board philosophy, not bits and bobs linked off of other bits and bobs with wires here, there, and everywhere. Just gives you plenty of opportunity to pick up RF interference and raise your noise floor and equal a poorer sound quality. And so it's a very, very simple and actually very clean looking design. And even to this day, we see a lot of amplifiers and audio products out there with wiring and looms of cables from one side to the other. But we've stuck with our philosophy. So that's the inside of our SA30 amplifier, which is a Class G amplifier. And the only wires that we include, other than the outputs, because the topology has changed slightly, are these two cables here that go across the top. There was no real way to make that any neater, and all they are is the feedback for heat. So they're just going to report back if the amplifier is getting too hot, then it can go into thermal shutdown. They're not actually part of the signal path. Otherwise, the entire audio path sits upon the board. In this case, in case of the SA20, that includes the D to A converter as well. And there's that power supply, and the topology has changed slightly with technology. The heatsink is now at the front rather than the back, which means our signal path is much shorter. Our input selection, which was on the front of the old A60, these switches here, so all of the input signals have to come all the way to the front and then all the way to the back again. And now we can do that with relays. It's part of allowing it to be remote controlled. All of the switching takes place at the back there, and the output stages are at the front. So we managed to shorten the signal path even further by just changing the layout over. So when the HDA range was launched, it was launched last year, and the HDA range replaced the Arcam A19, the A29, the A39, the A49, the C49, the P49, and the CDS27. It replaced a lot of products. And we replaced all of that with 3 products. So we were always going to follow up with further products. But we started on this process before the acquisition by Harman, and finished it after that acquisition. So, and they very much remain the product that were on the roadmap at that time. That's really evident if you use the CDS50. It's quite similar in the way it operates to the previous model, the CDS27, although there are some notable improvements. But one of the significant things about high definition audio, yeah. The reason we did that is because the FMJ range, which we discontinued, the FMJ brand and image on our products had been around for 19 years. And when we brought out new products, like when we brought out the A19 that replaced the A18, they looked identical. The appearance of the products never changed. And in our opinion, it was looking a little dated. We wanted to move on. And the way we consume music has very much changed the way we use our equipment. A great deal of us are not using CDs anymore. We're streaming content from services like Tidal or Qobuz or Spotify. It's very much music on demand. And there's so much digital content that reality is the only analog source we are now using is probably the turntable.
No processing inside. Do you process something? Filtering or something like
On the digital to analog converter itself, absolutely, that's always part of that process. But if you're talking about an analog input, there's no processing there. So the big thing about HDA was our integrated. This was the first range of integrated amplifiers we made that had a D2A converter on board. Previous models were all analog only, and you would have an off-board digital to analog converter either on board inside your CD player or in an off-board digital to analog converter of some description. But the feedback we got was people would like to see that functionality inside the amplifier. There is very much a drive that we see for people wanting to reduce the box count. It's so very easy to just add box and box and box and box and box. And you end up with quite a cluttered life and a lot of wires, and it's not necessarily something that sounds any better. So that's what drove the decision to take a step away from 20 years of FMJ and introduce HDA. So not being able to produce 7 new products all at once, we produced 3. And so, yeah, as I said before, it didn't take anyone much effort to figure out there would be more products. Those 3 products we brought out at the time, the CDS50 CD and SA CD player. This is a really great product, and this is the best-selling product in the range, which surprised us because primarily we are known for our amplifiers. But it's actually a very, very flexible product, and there are a lot of people, a lot of customers out there who still use CDs. Maybe they're not buying CDs anymore and they're listening to new music via streaming services, but they still have a CD collection that they've built up over the last 20, 30 years. And so the nature of CD players, with all those moving parts, they do fail over time. It was important to us to still be able to offer that. And as it turns out, it's very important to our customers. But we didn't make it as just a CD player. We make use of the digital to analog converter on board as well, so it has some digital inputs, so you can use it as a DAC as well. And it also has streaming services on board via our Music Life app. So internet radio, Tidal, Qobuz, Napster, and Deezer are all included. Now, the first of the 2 amplifiers we brought out at the time was the SA30. And that's 80 watt per channel, maximum output into an 8 ohm load. That's a Class G amplifier. And that has the same digital to analog converter on board that's in the CDS50. There was the subtle difference between the 2 was that in the SA20, you can change the digital filters. There's 7 options to choose from. They're very, very subtle differences. We defaulted to the one we thought sounds the best, but you might want to change that. And in partnership with our CDS50, we find we get best performance with a digital connection to the SA20 because the analog signal path is that much shorter. The other amplifier we introduced was to replace our outgoing A19, and that's the SA10. Similar power output to the A19, 50 watts per channel, was a Class AB amplifier. Again with the Sabre DAC on board, same number of inputs. And again, there are some digital filter options to select between. Not so many, I think there's 5 on this product, rather than the 7. And so it was time to bring out an addition to this range. It's the first addition to this range, and the SA30 has been a product that's been in extended development because it includes a lot of new features. A lot of our customers and people we spoke to expected the SA30 to be just a more powerful SA20, which the previous A39 was to the A29. But we wanted to do a little bit more than that. And so, yes, it is a more powerful Class G amplifier. It's 120 watts per channel rather than 80. And again, has digital inputs with the D to A converter on board, like the SA20. Little things we're adding. This one's going to include an eARC HDMI input. So you can get digital audio input from display devices. But we've also got an upgraded streaming platform. And that includes Chromecast, AirPlay 2. It'll be a Roon endpoint and MQA support as well. We've been demonstrating the SA30 here at the Highend show Munich over the last 4 days. We've been using Chromecast the entire time, just streaming from Qobuz. When you're using Chromecast or AirPlay 2, you can just use the native application of whatever streaming service you like to use. And we've all got a mobile device nowadays. So it's kind of our life. I know mine is. I'm on it too much, my wife tells me. So adding in that kind of support makes music playback really accessible and easy. No computers, no hard drives required. And we're agnostic, whether it's an Android device you have or an Apple device. We want to cater for everybody. But along with that, we include the functionality with our Music Life app that works on the CDS50. So we have not just internet radio, but Tidal, Qobuz, Napster, and Deezer services on board within that app as well. And the benefit of using that is if you're using Chromecast or AirPlay, if you disconnect your device or close the application down, then the music will stop. If you use the Music Life app, the music on the SA30, you can queue up a playlist and it'll continue to play, and then you can turn your phone off or disconnect it from the service. Now, this is a big one for us. If any of you are familiar with our AV products, our current line of FMJ AV products have included Dirac Live Room Optimization from the start. And Dirac Live Room Optimization is a really powerful tool, and it's something we have added to the SA30. It's our first HDA 2-channel product to carry Dirac Live Room Optimization. And I'll go into a bit more detail. Optimization, yeah. Yeah, absolutely. But first I will just go through a couple of questions I often get. And the first is, what's Class G? What is Class G? Well, yeah, exactly. Most people know Class A or Class D. Class AB we see very, very commonly. And that's the topology we would nearly always use. But to understand Class G, you do need to understand the others to know how it relates. Class A, which we all know, and love, because it's so simple. It's such a simple circuit that it's low distortion. It's hard to get it wrong, but there are some problems with Class A, and that's why Class AB exists and so on. It's why other classes of amplifier exist at all. The challenge with Class A is it's frightfully inefficient. For every, at best, it's 25% efficient. So for every 1 watt of energy you deliver, you burn off another 3 as heat. Most Class A amplifiers are very low power. We do use Class A in some of our smaller devices. We used it in our Arcam headphone amplifier. It doesn't need high power, it's for headphones. That was Class A. Yeah, exactly. And it's low distortion because unlike Class AB, you're not switching between different transistors. Now, Class AB is called Class AB because it's partly Class A, it's partly Class B. And Class B you never see, not in audio, because it introduces a hell of a lot of distortion. And it does that at the point it's switching between the two transistors. In the case of an AB amplifier, there is biasing applied, and what that means is the application of the transistors overlaps. So around 0 volts, they are biased by maybe 50 millivolts. So the negative transformer will actually switch off at plus 50 millivolts, and the positive at minus 50 millivolts maybe. And that all depends on how the amplifier designer has specified it and tuned it. But within that range, the amplifier is effectively operating in Class A. And that reduces the distortion inherent in Class B significantly. But the more you bias it, the greater that bias range, the more inefficient the amplifier is. Whenever it's within that range of the bias, it's creating heat again. So as an amplifier designer, you're always struggling with wanting to get the best sound and not end up making something that's so inefficient you have to add lots of metal work to it to dissipate the heat energy. So that's Class AB. Class D amplifiers we've mentioned, and that's a super simplified diagram up there. But a Class D amplifier, some people call them digital amplifiers. They're not digital. Sometimes they are made with digital inputs, but they're not digital, strictly speaking. A Class D amplifier uses a clock to modulate the incoming signal. Now, the benefit of a Class D amplifier is that the output stages are only ever fully on or fully off. Nowhere, not in between. So, in that regard, you significantly reduce inefficiency. On or off, simple. And they can actually be very small because they don't have to dissipate vast amounts of heat as either. But that pulse width modulation is a significant source of noise. There are various different ways of getting around that. Whether it's switching it faster is often something that's cited, and certainly that is how Class D amplifiers have improved over time. And also the actual FETs that are used are quicker at switching, because they don't instantaneously swing from peak voltage to minimum voltage. That takes a period of time. It's small, but it takes time. And that time that you're switching is inefficient and generates heat. So again, you're back to that. Switch it as often as you can to increase resolution and dynamic range. You also increase heat output. So in small applications, they have to switch it slightly slower, but in some of the amplifiers you'll see here, the more luxurious amplifiers, they'll switch it very, very fast. We're talking megahertz. But we use Class D in some applications in small products. But we don't use it in hi-fi products where we can accommodate a linear amplifier or a Class G amplifier. In this case, we will do. So, Class G, there's two things here. Class G itself is everything to do with the power supplied to a Class AB amplifier. So, it has a pair of positive and a pair of negative voltage rails, rather than one. So if the peak supply voltage to an amplifier is 50 volts positive, 50 volts negative, in a Class AB design, that voltage is across the output stage all the time, even when it's in idle. In a Class G amplifier, we will still have that high voltage positive and high voltage negative rail, but we'll also have a lower voltage one. That might be 5 volts positive and 5 volts negative. And so when we are only operating within those smaller outputs, the larger voltage rails are actually switched off or not switched into circuit. And that means we dissipate less heat, less energy that's not otherwise required. And actually, the benefit to us was that we can increase the biasing on our amplifier. So instead of operating biasing of 50 millivolts, we can operate with biasing of 5 volts. And actually, we vary that biasing. So when the amplifier is idling, the biasing is reduced so that we dissipate less energy. And as the output increases, the biasing increases up to that maximum. There are some challenges with Class G. There's no simple solution because at the point you switch between one voltage supply and another, you can very easily introduce noise. Switching from 5 volts to 50 volts, bang. And then if you're doing that on and off 4 times every cycle, that's a lot of harm. That's a lot of noise. So we don't just switch it. We have part of the amplifier circuit is what we call a lifter board. It's not a board because it sits on the same board as we looked earlier. And what that does is it raises the voltage from the minimum up to wherever it's required, and then down again as that cycle continues. And it always maintains a 5-volt headroom. And that means we can realize the full dynamic output of our amplifier, but only ever drawing the power we need. A lot of manufacturers would do that with a switch mode power supply, but we can do that with a linear power supply. And lower noise and greater current delivery is the result of that. So we achieve greater efficiency by switching between a full voltage, full set of voltage rails and a small set of voltage rails. And with that extra efficiency, we can increase the biasing on our amplifier for greater Class A operation, which is lower distortion and hence greater sound. And I do encourage any of you, if you get the chance, not just to listen to the SA30, but to listen to the SA20. It's a great comparison to listen to the SA10 versus the SA20 because it's such a big difference, and yet they're identical in size. Dirac Live was the other key feature. Have any of you encountered Dirac Live before? Heard the difference that it makes on an audio system? No, Dirac is a company. Yeah, it's a company. It's so Dirac Live itself is software. It sits on a computer like one of these. And it's a tool. It's not an automatic thing. It's got a quite nice wizard, so it takes you through the steps. But it's the process of creating a Dirac Live profile includes taking measurements with a microphone, using the software, taking anywhere from 9 to 17 measurement points across the listening area, depending on how wide the listening area is. The more measurements points, the better, because the better the average will be. No, they are targeted points. Yeah. So there is a main point that's right in the sweet spot, and then distributed points around that depending on how wide the listening area is desired. And with that, you can use tailored target responses. So you can create your own target. You can tell Dirac what you want it to sound like. And with that, it creates frequency response correction and impulse response correction. And all of that gives you, well, primarily, this should also really should be the other way around. Primarily, it reduces room coloration by, in the low frequencies, reducing resonances within the room. especially at low frequencies. Anything sub 200 hertz is really key. That bass that's where there's a resonance in the room is slow. It takes time for the energy to build up, and it takes time for the energy to dissipate. So by correcting for that, not only do you get improved staging because it's not clouded, but you get deeper and tighter bass and better clarity. That's what the software looks like. That's one of the measurement arrangements for taking 13 measurements. So you can see the main listening positions and the measurement points you would take around that. So it's quite powerful and quite focused. And with that, this is an optimization for a subwoofer on one of our AV systems. So you can see, in this case, at low frequencies, how that particular subwoofer was measured out. That one was measured over 17 measurement points. And you can see the output isn't particularly linear, which is quite normal, especially if it's a subwoofer, especially if you've tucked it into a corner, which we like to do because that corner gives us lots of boundary gain, so we get even more low frequency output. But we want to correct it to get a more linear output. So we use Dirac to reduce the resonances and account for the drops in output where you have a null. And that means we can get a much more linear response from the amplifier. One of the nice things about using Dirac, for us, in the Harman Luxury Audio Group, is that we've developed, and I say we've developed, it was developed over a long period of time by Floyd Toole and Sean Olive, who are, Floyd's retired now, but they worked for, and Sean still works for Harman. They completed extensive scientific measurements to calculate what a loudspeaker should sound like. And those were both subjective and objective listening tests, and they were double-blind in the case of the subjective listening tests. And from that, we were able to create a target curve based upon those measurements and the results we got from both trained and untrained listeners. And we were able to create our own target curve, and we used that target curve to develop all our loudspeakers. And so now, with Dirac, if you use one of our amplifiers from one of our Arcam amplifiers or Lexicon amplifiers with one of our JBL or Revel loudspeakers, we can optimize the output within the room using the same optimization curve that the loudspeakers were created with. You measure the room itself. Yeah. The room itself is measured, so you take the microphone. Yeah. Not automatically, no. No, this isn't an automatic bit of software. It's a software on a computer, USB microphone. There are a number of different microphones out there that could be used, and we will supply one in the box that can be used. And you use that microphone to actually measure the room itself that the end user is using with the SA30 and whatever speakers they're using. And with that, you'll get a measured response, and you can create a target curve to correct that measured response. We buy the full license from Dirac, so there's no additional costs. It's the full range, 20 hertz to 20 kilohertz correction. And you can use as much or as little of that as you like by using these curtains to adjust where Dirac is, the frequency range that Dirac is in effect. We don't use Dirac to try and extend frequency response. So in this example here, where we've created this corrected curve, we didn't try and make this subwoofer reproduce lower frequencies than it's actually capable of. You're just going to end up overextending the drive unit, generating a lot of power within the amplifier, and achieving very little. So we never use it to use Dirac to do that. We're literally using Dirac to make the measured output more linear. But by doing so, by creating a set of mixed phase filters to correct these peaks and troughs, you naturally correct impulse response. So in this case, we went from an impulse response that looked like that to an impulse response that looked like that. Yeah. And what Dirac can't do is it can't treat reverb or decay. If it's in the room, it's in the room. It can't absorb it. It can't say that reflection is bad. I'm going to not output a bit of sound that creates that reflection. But if it has a particular harmonic, that will come up in the measurements and that can be corrected for. So just in quick summary, the SA30 expected in stores and for demonstrations this September. And in Europe, we expect to be selling it for €2,400. That's me done. If there's any questions.